So you can say that electromagnetic waves are the disturbance in the electric and magnetic field. Disturbance in electric and so one more property is that both fields are perpendicular to each other. By perpendicular, I mean both fields are at 90 degree to each other. Okay, all the electromagnetic waves are transverse waves. What is transverse wave?
The wave that has is perpendicular to the direction of propagation.
Yes. So you can say that all of the electromagnetic waves are transverse waves. All of them. So it becomes a similarity between them. So since they all are transverse, so if they travel in the vacuum, so their speed is same, which is 3.0 into exponent 8. Okay, so in vacuum, the speed of all of the electromagnetic waves are same, which is 3.0 into exponent 8. But in other mediums, like if we talk about in any other medium, another than vacuum, so the speed of the wave are different. They are not same. But only in vacuum, I am saying their speed is same, which is 3.0 into exponent 8. Okay? And
Okay, sir.
they all follow a law. Velocity equals to frequency into lambda. They all follow this law. All electromagnetic waves. And all the electromagnetic waves also follows laws of reflection, diffraction, interference, and polarized wave. Polarization. We will study about polarization later and Doppler effect as well.
So do we need to know about refraction?
No, you will get only an idea that is needed. The diffraction is the bending of the light. That's it. We don't have to go in detail.
Okay.
Diffraction is the bending of the light when we change mediums. So after this, we have one more thing in electromagnetic wave, which is the range of frequencies and wavelength. Since all of the electromagnetic waves have different frequency and different wavelength. So if talk about frequency, so tell me what is the highest frequency, which wave has the highest frequency and which wave has the lowest frequency.
Gamma has the highest frequency and the shortest wavelength.
Yeah. So frequency increases, you can say, from radio to gamma rays. So you know that the velocity, the frequency and the wavelength have inverse relationship. So if the frequency is greater, wavelength is shorter, right? Smaller, you can say. So the shorter the wavelength, the higher the frequency. So if the gamma rays has the lowest wavelength, highest frequency but lowest wavelength. After this, we have visible lights. So, do you know the visible lights? What color are they?
Red, orange, yellow, green, blue, indigo, and violet.
Yeah, you can say WebGyor. We remember it by using WebGyor. So, wavelength is increasing in this order. So, you can say violet, blue, green, yellow, orange, red. Yes, right. After that, you have also have to learn the wavelength of these waves. Okay, I will send you a table of this wave. You have to learn the wavelength of this wave because in the sometime in the question they ask you the wavelength. Not exactly, but the range you should know it. So I will give you the table later. You can just memorize it. Okay.
So it won't be given in the exam, right?
I sorry what?
It won't be given in the exam paper, right?
Yeah, it won't be given. They just ask you the range of wavelengths, so you should know it.
So we can put any value in the range.
Yeah, you can put any value in that range, but that should be in specific range. Like if the radio wave has different range, the gamma rays has a different range. So you should know that in specific range of each wave.
Okay, sir.
Yeah, so the next topic after the electromagnetic spectrum is Doppler effect. So start reading the Doppler effect. Can you see it? Is it visible?
Yes,
Okay.
sir.
Okay.
It is the change in frequency heard by the observer when there is a relative change of speed between the source and observer. Consider a source ambulance produces sound with the frequency Fs.
FS.
The speed of
FS.
Fs. The speed of sound is v, which is 350
30 of
or 330 or 340 meters second negative 1. The frequency heard by observer is Fo.
yeah, so Doppler effect means a change of frequency heard by the observer. Because you know if an ambulance is passing in front of you, so if the ambulance is nearer to you, you will listen a high frequency sound. But if the ambulance is passing through you and has reached a maximum distance to you, then you will listen a very low frequency sound. So this is because due to a Doppler effect. Actually, the sound or the frequency of the ambulance is not changing. It is same, but the distance is changing. So due to that, what is happening? The frequency listened by you or the observer is changed. So that's what Doppler effect is. So if we take the sound by the frequency of the source, which is Fs, it is the frequency of source which remain constant because the ambulance is producing sound which is constant sound. It is not changing. But still you listen a changing frequency sound. So you can say that Fo is the observed sound, the frequency of the observed sound. So is this thing clear about the Doppler effect?
Understand?
So if we take case one, if the source is moving towards the stationary observer, then the frequency of the sound by observer will increase, and this observed frequency is given as so FO is equals to source frequency multiplied by speed of the you can say ambulance or any other sound source V upon V minus Vs. So the V is the sound speed of sound, and Vs is the speed of moving source. Okay, Vs is the speed of
Okay.
moving source. You can say in this case ambulance. So if the sound is increasing, we will use this formula. And case 2 is saying if the source is moving away from the stationary observer, like it is going away from you, so in that case, the frequency heard by the observer decreases. Obviously, if it is going away from you, you will listen a low frequency sound, so frequency would decrease and wavelength would increase, obviously. Hence, this observed frequency is given by the only thing changes is instead of minus, there is plus in the denominator. So obviously, if it is addition in the denominator, so the denominator would be greater, making your observed frequency lower. And if the ambulance is going away from you, obviously the observed frequency would be lesser. So that's why it is making observed frequency lesser. So you can remember by this thing. In the above case, the frequency was increasing. So that's why we subtracted it. So the denominator becomes smaller, making the observed frequency greater because it is in inverse relationship, right?
Okay.
So these are the only two cases for the Doppler effect, the formulas cases. Okay, we can also observe Doppler effect in light as well. Not only in sound, but in light as well. Let's see how can we observe that in light. So when a distant star or any other light source is moving towards or away from the stationary observer, then the color of the star seems to be different or vary. And if color of the star is towards blue, indigo, or violet, then it shows that star is moving toward us. If the color of the star varies from green to yellow or orange or red, then it seems that the star is moving away from us because of decreasing in frequency. So if you see a distant star in the sky and it is giving you the color of towards blue, indigo, violet, then you can say that the star is moving toward us. It is coming toward us. But if it shows the color of green, yellow, orange, so it means they are moving away from us. So that's how Doppler effect in light we can study. Is it clear that how in the lights it is possible Doppler effect?
Sir, could you repeat one more time?
See, you have heard that stars move. Yes or no? A distant star has been fallen as well, so they move. Let's make this thing clear.
Yes.
Okay. So if the star moves, so obviously the light by the star changes. So if it is moving towards you, like it is coming towards your area, you can say, so the color of the star would be something in the shade of blue, either blue, indigo, or violet. So you can say in that case, the star is moving towards you. But if the color of the star changes or varies from green to yellow or something like that shade, green, yellow, orange, or red, so in that case, you can say that star is moving away from us. So away from us mean the frequency decreases. So that's why if someone asks you that if the frequency decreases, the color would be either green to yellow, orange, or red. Now is it clear?
Yes, sir.
So that's how in the sound and the light we can observe Doppler effect in both cases. Okay, now read this question.
A train is moving in a straight line on the railway track. Have a whistle which continuously emits sound of frequency F. A woman standing on a side track hears the sound of frequency 0.85 F. The speed of sound in air is 340 meters second every one. Calculate the speed of the train.
speed of the train, which means we have to find the speed of the source. So you know that the observed frequency is 0.85 f, right? It is lesser. So
Yeah.
what it is lesser. So you can say that that train is moving away from you. Yes or no?
Yeah.
You can say the frequency of the source is equals to f, and the frequency observed by a woman is 0.85 f. So it is in decreasing case. So we will add in the denominator. So let's write the formula first. So it is FO equals to Fs V upon V plus Vs. So observed frequency is 0.85 f. Frequency of the source is f. The speed of sound is 340. Plus we have to find the Vs as well, the velocity of the source, the speed of the train. So F cuts, it would be something like 0.85 into 340 plus Vs. And then you have to make subject Vs and then just give the answer. Is it clear till here?
Yes, sir.
Can I read this question?
Two identical waves are produced by a process at point P and Q. The waves travel along different paths and reach at point R. Both waves have a wavelength of cm and waves are in phase at R. What is the phase difference between the waves as they leave P and Q?
So a diagram is also given to you that a distance from P to R is 80 centimeter and the distance from Q to R is 100 centimeter. But it is saying that at R both are in phase, which means the phase difference is, you can say, as zero because they both are in phase, right?
Okay.
So in phase means you can say, you can't say that it is in like 180 degree or 540 degree. Either it would be, okay, leave this one thing. First of all, first calculate the we have to find the phase difference between the waves as they leave P and Q. So you know the distance between P and R and Q and R is different. So at the starting points, the phase difference would be different. We know at R the phase difference is zero, but at P and Q it is different. Why? Because they are starting from different point, and obviously the length is different. So obviously the phase difference would be different. Is this thing clear?
Yes.
So let's calculate the phase difference at the P and Q. So we know that the wavelength is 6 centimeter. So you can say that 6 centimeter is equals to how many angle?
360.
Obviously. Now let's calculate the power difference between P and Q, which is 20 centimeter, right? 100 minus 80. Yes or no?
Sorry, sir?
I'm saying that the distance between P and Q is 20 centimeter, 100 minus 80.
Yes.
So I'm calculating the phase difference for this 20 centimeter, that difference, right? Because they have asked us at the start. So at the start, the difference between P and Q is 20 centimeter, right?
Yeah.
So 20 centimeter, the phase angle difference or the angle would be x. So x equals to You can say it would be, you can say it would be 1200. Okay, 1200. So angle, it is the angle coming, 1200 angle. So see, we just have to find a phase difference between the wave as they leave P and Q. So in the 1200, you know that if the angle is 360, then 720, then add 360 in it, so it becomes 10. 720 plus 360 is 1080. So till 1080, the waves are in phase, yes or no? Because we know for the waves to be in phase, the phase difference would be either 360, 720, 1080. You can say it is a constructive interference, yes or no?
Yeah.
So for waves to be in phase, this should be the phase difference. So, but the angle is 1200. So for finding the exact phase difference, we would subtract 1200 by 1080. Why? Because we know till 1080 the waves are in phase, but after that they are not. You can also say the next point for waves to be in phase would be 1080 plus 320, 1400. At this point as well, the waves would be in phase, and then add 360 further on. But since it is 1200, it is in middle of it. So we know that at this point they are not in phase. So we will just find 1080 minus 1200 is 120. So you can say the phase difference or the angle between them is 120. It is the difference between them. Is it clear?
Yeah.
So always remember that if that angle is coming larger, then you have to subtract it by the waves in phase. And we know that when will be the waves are in phase when the angle is either 360, 720, 1080, 1400, and further on. Just add 360 in all of them. So for more clarity, you can read this as well. Just read it and tell me is it clear now or not.
Yes, it's clear.